A more general term that slope comes from is called the rate of change, which is how things change. It's a way to explain how things change. The definition of a rate of change is it's a ratio that shows how one variable changes with respect to another. So what that means is rate of change, like if you imagine, I'm going to draw off the side like a little graph, a car like driving through town and there's stoplights and stuff, right? So they're like distances over time might be like, different steepnesses. It's not constant. There's different rates of change between any 2 points here, okay? Those are rates of change. You'd have to be like, well, what's the rate of change between here and here, here and here, here and here? But when we get to a linear graph or a line that has a constant rate of change, so I like to write that over here, constant rate of change, that is called the slope. It's a specific type of rate of change for a line when it's constant, okay? So that specific rate of change called the slope, it's written as a ratio, and this ratio, the number, is always written vertical change, which in math we call the rise, to the horizontal change, which we call the run. So it's always a ratio of rise to run. Another way I like to visualize it is like rise, you'll hear people say rise over run, this ratio. And rise can mean vertical, and run means horizontal. So this remains constant for any 2 points on a line forever, which is cool. Because what that means is we can get the slope of a line using any 2 points on the line. Any two. It's always the same. And it's actually always the same because of similar triangles, but we'll maybe get into that a different day. Okay? And we write it, though, every time we write it as a fraction in simplest form. That's like an organizational and a communication thing. And this is kind of weird and fun. The variable we use for slope is m. Remember how we talked about like the constant of proportionality, we used k? For slope, we always use m. The speculation when I Googled it was the reason for m is I think there's a word, something like monter, which means to climb in French, which kind of makes sense. Like a hill has slope to climb. I think that's kind of fun. So even if that's not the reason, that's the way I want to imagine is the reason. All right. So this next part we already explored with our Desmos activity earlier. We're going to focus on positive slope, negative slope, zero slope, and undefined slope, okay? So who can unmute just for a moment and remind me what positive slopes look like? Left to right. Think about slope, dude. Nate, you ready?
Positive ones go up, but not like straight up.
Yeah, left to right, they're going uphill would be one way to think about it. Left to right. All right? I have a volunteer for negative. What about you, Jaden? Yeah, left to right. Nice. Negative, from the OG slope dude. Okay. A volunteer for zero slopes. This is zero fun was the thing from the video. Nolan?
It's flat because x times 0 is 0.
Yeah, we're going to use the word horizontal, but yeah. I saw you doing a TikTok dance to it. I like that. Okay. And I need Ace. What about undefined? What's that one going to look like?
It would just be straight up and down.
Vertical is the fancy word. Yes. Undefined from slope, dude, right? So those are the big ideas. Positive, negative, zero, and undefined. Now, we're gonna move from those big ideas, again, to recap the big ideas. The larger the slope, the steeper it is, larger absolute value. Positive slopes go up from left to right. Negative slopes go down left to right. Zero's horizontal. Undefined's vertical. I think that's all the big ideas we discovered on Desmos. Now let's get to some application. So in math, we need to be able to give a number for slopes, right? This thing is this thing. Just a reminder, the slope is the ratio of the rise to the run. Now to do this, you can use any 2 points on any line. So like number 1, they gave these 2 points. Let's just use these 2 points, okay? I'm going to make them pop a little bit on your screen. And we're looking for the rise and run. So I like to trace like the path I'm going to count. So I'm going to count how it changes up and down and how it changes side to side. And up and down, I get 1, 2, 3, 4, 5, 6, 7. And side to side, I get 1, 2, 3, 4. So that means my slope for that line is 7/4. I've got a rise of 7 for every run of 4. Forever. I hear someone talking. One sec. I like always go left to right, but let's say you traced a different path. Let's say you went like this. Okay? The up and down would still be your rise, the side to side would still be your run, and you would have to make sure that you have rise over run, and this line left to right goes up, so it'd have to be positive. So I always go left point to right point, and I always do the rise first because I'm looking for a rise to run. So let's look at another one. Let's look at number 2. And 2 picks out 2 points, but I'm going to pick different points, and I'll show you why. I'm going to pick those points because they're closer together. And watch what happens when I trace my path left to right. I get a down 1, right 3 for a slope of -1/3. Now let's say you use the points they gave you. You're fine, you could. The points you were given were that point and this point. If you use those points, you're going to have a down 3, right 9, which is a slope of -3/9, which in simplest form is 1/3, okay? I'm a fan of just using points that are close together so I don't have to simplify. And so another place I see kids get hung up is they're like, I have to use the points. Those points on the line are just reference points. How many points are actually on these lines? Infinite. The whole line's points, right? So when there's a dot, it's a reference point, and usually you want to pay attention to reference points. But if later you're going to get lines with no reference points, you'd have to pick your own points, okay? And then real quick, 3 and 4, those ones are kind of simple. We've got a slope of 0, and we've got a slope of undefined. That's straight from slope, dude. Now, let me explain to you why these work now that we got those ratios in mind. So let's say we go from this point to this point. My rise would be 0, and my run would be 1, 2, 3, 4. And 0 divided by 4 is 0. 0 divided by a number is 0. Now, if we look at number 4, and we use these 2 reference points, my rise would be 1, and my run would be 0. And you can't divide by 0. That's why we get undefined. So if you can't remember which one's which, set up the slope. One gives you an answer of 0, the other gives you an answer of undefined, even in your calculator, all right? So don't just guess, be like, oh, I know it's one of these. You could actually put it in the ratio, and the ratio will tell you if it's 0 or undefined. So I'm looking at number 5, and I'm just going to keep modeling how I go about these, all right? So for number 5, I am going to use the points given, and I like to trace my path I'm going to count. And I go up 1, 2, 3, 4, 5, over 1, 2, 3 for 5/3. We would keep that improper because as a fraction, like let's say we had 1 2/3, that means up 1 2/3 over 1, that's hard to count on a graph. So we usually keep them as improper fractions. And you might recall, throughout the whole year I've been encouraging improper fractions. This is part of the reason. All right, let's do a little waterfall action. In the comments, don't hit enter. Just type it in. Don't hit enter. Okay? So
for which one?
For number 6. Number 6. You're typing in your answer for number 6, but you're not hitting enter yet. Just typing it in.
Well, it's going to be a direct message to only you.
Yeah, that's good. Okay, hit enter. Whoa, I got 3. I got -3. I got 3 over 1. I got -3 over 1. All right. So, first of all, let's imagine Mr. Slope Dude right here, okay? What would happen? Would it be like nice negative or puff positive here? Nice negative, right? So some of you made a mistake there. That's a good mistake to make now. So let's trace the path. I'm going to use the 2 given points, and I always go left to right, rise first. So it looks like I'm going down 1, 2, 3. So down 3, right 1, and negative 3 over 1 just is a negative 3. So that line right there has a slope of negative 3. All right, let's waterfall again for number 7. Don't hit enter yet. Oh, I guess you guys can hit enter, right? Because I changed the setting. You can only message me. So go for it. Start hitting enter.
Mr. Mac,
Yeah.
for number 12, could the answer also be 3 over 2 if you use the point that is a little bit closer?
So for number 6?
No, number 5.
Okay. So this point right here looks kind of close, but it does not go through that. Perfect. Yep. So you want to look closely. It is close to 3 over 2, but it's not 3 over 2. It doesn't quite cross there. Good question. So some answers I'm seeing for number 7. I'm seeing 2, 2 over 1, 4 over 3, 4 over 2. All right, let's take a look. So I am going to use this point and this point. You could use the other point and you still get the same answer. But if I go rise and run, up 2, right 1, I get a slope of 2. Now let's say you use the given points. What that's going to do is give you a rise of 4, a run of 2. And guys, 4 divided by 2 is 2. We always want these in simplest form, all right? So a lot of us were real close. We either got it or we're real close. And then always think about Slope Dude, right? Slope Dude's down here just skiing up a hill somehow. Whew, he's getting real tired, right? Uphill. All right, number 8, waterfall for me. Throw it in the chat. I'm seeing some stuff come through. I got 1. I got negative 1. I got 1s and negative 1s. I got a negative 4 over 4. Make sure you simplify answers. All right, let's check it out. I'm a rebel, so I'm not using the given points again. I'm using this point. I'm using this point. Check it. Down 1, right 1. For a slope of negative 1. That's how I roll. Now, let's say use the points. And you got negative 4 over 4. Guess what negative 4 over 4 equals, friends? It equals negative 1. All right? All right, let's waterfall for number 9. Let it flow. Some stuff I'm seeing for number 9. I'm seeing 3/4. I'm seeing negative 3/4. I'm seeing lots of negative 3/4. I'm seeing tons of negative 3/4. Hey, I want to ask you a question. Braden, my main man, Braden. How could you tell if this one's positive or negative before you even do anything? Left to right, it's going down. All right. Do you think it's yelling timber? That's what I want to know. Okay. So I'm going to pick the 2 points given. I like to trace my path. Down 3, right 4, for a slope of negative 3/4. Cool. All right. Waterfall me on number 10, all right? Put it in. I'm ready. I'm seeing some negative 5, some negative 5 over 1, some more negative 5s, some 5s, some 37 and a halves. Who is that? No, I'm joking. I just made that one up. Nobody did that. Okay. So we got lots of negative 5s. Let's check it out. I'm going to use the given points. 1, 2, 3, 4, 5 down. 1 to the right for a slope of negative 5, friends. Man, that did not show up at all. I got you. Down 5, right 1 for a slope of negative 5. Cool. All right. You guys are feeling it. You're feeling it. I've got this page of practice. What I'm going to do is I'm just going to have you practice it. I'm going to have the answers on display so you can check as you go, and then let me know if you have a question. All right, so one more time back to the whole group chat after seeing my answers. I would like someone to volunteer to tell me what I did wrong and how I could get it right. Just put your hand up. I'm looking for volunteers here. I don't see any hands, guys. I don't. Oh, Ezra. Tell me what's up.
Number 14, you put it as negative 2 over 3, but it should be positive 2 over 3.
Okay, let's check that out. So if I went up 2, right 3. Did I land on the line?
Oh no, sorry. You should go down 3 and then down 2 and then right. Oh, I was looking at the wrong one. Okay, yeah, you should go down 2 and then right 4. So then that should just be negative 1.
Yeah, in fact, if I were to do this, I would go down to this point. Down 1, right 2. Now, here's one more thing I want to show you real quick, okay? So you see those two triangles where there's like a 1, 2, and then a 2, 4? Do you guys remember when we did similar figures earlier in this year, and there's that proportion that's made like corresponding sides form a proportion, 1 is to 2, 1 is to 2, as 2 is to 4? That's why slope works from any 2 points, okay? Because in ratio, they increase at the same time, because really what's being made over and over are similar triangles. It's pretty cool stuff. All right, there it is, friends.